This is the Prakash Sastry, Professor, Associate Dean, Student Welfare Department of Civil Engineering, Doctor University. So today we are going to continue with our previous session with the example of errors in taste and chunk. Now we are going to do the next one, which is compass survey. So introduction towards compass is nothing but compass is a type of surveying methods. So you know that previously we have seen about chain and tape. So chain and tape are used to measure the distance between your 2 points or else two survey stations. But now we are going to see compass surveying. So compass surveying is a type of surveying method which is used a magnetic compass to measure the direction of survey line, right? So it gives you the bearing. Right? With respect towards your magnetic north, we are going to measure the bearing of line. With the bearing, with the forward bearing and back bearing, we are going to calculate the included angle. Okay. So definition starting with the compass surveying is that in which a magnetic compass is used to determine, as I said, bearing of a survey line. So it indicates the direction of survey line related to Earth magnetic north. Okay. So that north is magnetic north of the Earth, and the distance between a point is measured using a tape or other measuring equipment. So as I said, it only give you the bearing between your lines uh, from your magnetic north of the Earth. So, type of compass, first one is hand or box compass. So, it is less accurate but still widely used. If you are dealing with only minimal deviations, you can use this hand box compass. Then, prismatic compass, it is highly accurate and widely used one. So, it is a traditional method where they are using prismatic compass, which they use to find the bearing. It is high accurate. Okay. Right. Again, these two are low accurate. So starting with the surveyor compass, it is less accurate and less commonly used. So it has some two eyepiece on both sides. Then front end compass is a compass which is highly accurate and most but less commonly used. Front end compass it has an altitude meter. So you can use this particular compass to measure both your altitude and the bearing. Right. So these are the compass. So this particular side is you can see that is low accurate and this will give you a precise and accurate bearing of your particular line. So now I'll see in a detail way what is prismatic compass. As I said, it is most widely used compass. It has a graduated circle attached to the box. So you can see there's a graduated circle on this which is attached towards the box, and it read a bearing while sighting on the object simultaneously, right? So this is your eyepiece, this is your object piece. You have to focus on the object piece and you have to note the reading. So this is your magnetic north. With respect towards your magnetic north, it will give you the measurement, right? So the design improve the speed and accuracy. So about 30 minutes of work we can mention because the minimum degree is 30 minutes, right? So it is lightweight, as I said, it is portable and suitable for field work and rough terrain. Okay, so it is very lightweight and very compactable equipment which is used to measure the particular bearing of a line. So we'll continue to the next one, which is a surveyor compass or circumference stator, right? So this you can see in the prismatic compass, you have the objective and eyepiece here. Both are eyepiece and you can use both as eyepiece and objective. So this is very less accurate when compared to that one because it has a fixed graduated scale moving overall. So you can see this is a graduate scale is fixed and your needle is moving. Right? So there is a, level, spirit level to indicate your horizontality of your compass. So with the help of the prism, right, it is relatively simple but accurate than historically. It is commonly used in cadastral and boundary surveying. Okay, right. So it is used in cadastral and boundary surveying, though it is now mostly replaced by precise equipment. So this compass is replaced completely by your totalization because your totalization will directly give you the inclined angle. So the thing is, so if this is your line, right? So this is your line. So the make this as your north. So you can only measure the angle, I mean bearing, and you have to measure the bearing to this line, right? With respect towards your magnetic north, right? Then by suitable calculation, you have to find the internal angle, right? Included angle. So this is completely replaced by your totalization, which will give you direct included angle uh, in an instance, right? You don't want to do any calculation. Every calculation will be done by the equipment itself, and it will give you the direct enclosed angle. And sum of enclosed angle also you can calculate. Now, hand compass or pocket compass. So that is the handheld compass. So this is box type compass. As I said, this box type compass is used only in your line tabling, right? And this is handy compass, which is used widely for your directions. Not if you only need to find a direction, you can use this without any perfect bearing readings. Right? So it has no special sighting arrangement. So no focusing and no special sighting arrangement or that. So it is employed for rough bearing observation. So it is used roughly. You cannot exactly measure whatever it is needed. So you can roughly measure a distance of a compass suitable for some directions marking on your plan. For example, so this is your plan, right? So you just want to mark the north on your plan, right? So you will take a grad drawing sheet and exactly mark and which direction your north is located with respect towards your building planning, right? So this north will be marked by using your this handheld compass. You don't want to do any bearings or anything. Just you want to know the directions and orientation of your plot or your field. So you can use this handheld compass or a box compass. So next is an widely used geologist compass, which is a Brunton compass. So this compass is more advanced instrument and it is very expensive, widely used in geological mining and topographical survey, right? So it combines a feature of compass and a clinometer. We can see there is a clinometer which is inside, which is present inside. So it allows a surveyor to measure both horizontal bearing and a vertical angle. Okay, right? When you are dealing with any fault or a geologist, you want to find inclination of your fault. It is equipped with a mirror for sighting. It offers high accurate and extreme versatility in a field study. Okay, you can use any this. So this is a Brandon compass. You can use it very widely. The focus point IPC is here. So it is equipped with your mirror. So you can easily identify the elevation marking, right? So when you're dealing with any fault identification, a geologist used to measure the inclination of your rocks or anything. So they can use this Brunton compass, which is widely used for this particular purpose. It is very expensive. It gives you high accurate measurement, which can be precisely recorded, right? So when you are using this kind of compass, it is very precise and it is not commonly used because you are geologist or other you are topographical surveyor. They'll use this kind of compass for their measurements. So now we are going to see bearings. So what is the bearing? As I said in the previous slides, we are going to measure only bearing, not the enclosed line. So a bearing of a survey line is an angle formed between the line and the magnetic north, right? So for example, so this is your line and this is your magnetic north, right? So when you are measuring this inclination, so inclination is measured from your magnetic north in such a way. So this is your bearing of this line, okay, right? And this is a bearing which is measured same from the magnetic north. This is your back bearing. So this is theta 1 and theta 2 forward bearing, and this is your back bearing, right? So when you subtract this theta 2 from theta 1, you will get the included angle, right? So this angle formed between the magnetic north of Earth and the line is called as a bearing, okay? So the bearing can be a whole circle bearing, so which is measured from 0 to 360 degree, and it can be quadrantal bearing, so it is reduced from 0 to 90 degrees specific in a specific quadrant, right? So 0 to 160 is a whole circle bearing, and if it is splitted into 0 to 90 degree with specific quadrant, that is a quadrantal bearing. Okay, right? So this is whole circle bearing, and this is your quadrantal bearing. You can see the range is between 0 to 360 degree because it's a complete circle, and the measurement was taken in a clockwise, right? So when you are dealing with quadrantal bearing, right? So it has a range degrees from 0 to 90 degree with the nearest cardinal direction. So with the nearest cardinal direction, you can mark this one. We'll see this thing in upcoming slides and explained in a detailed way. So, type of bearing. Okay, we are segregating your type of bearing. So, first one is magnetic bearing, second one is true bearing, third one is arbitrary bearing, right? So, a magnetic bearing is an angle between the survey line and the magnetic north. What I have said earlier. You can see here. So, this is your magnetic north, and this is your true north. because there will be variation in your true bearing. So, right? So, when you are measuring an angle between the magnetic north and the line, that is called as magnetic bearing. Right? When the angle between a survey line and the true north of geological north. So, the true bearings obtained by correcting the magnetic bearing for the magnetic declination. So, this magnetic declination is happened due to some I mean, some object which is attracted by your magnet. So, your magnetic needle will be deviated due to some magnetic object surrounded by, so which leads to magnetic declinations, right? So this has to be corrected. So magnetic bearing is a bearing where your magnetic north is taken as 0 degree. A compass point towards magnetic north pole, which is not a true north. Okay, because your magnetic north is inclined by 5 degrees. Okay. On South Africa, magnetic north will always be the left and west of the true north. Okay, so in South Africa, your magnetic north will be always towards your left, that is west of your true north, right? So this is your my true bearing. Okay. Then the angle made by a survey line with reference to arbitrary meridian is called as arbitrary bearing, right? When you are measuring angle with respect to arbitrary bearing is nothing but you are measuring your bearing for your requirement. You are keeping your north as per your requirement, and from that you are measuring your bearing. So that kind of bearing is called as arbitrary bearing. So which is applicable for a small area. The magnetic bearing and true bearing are applicable for the large areas. So next we are going to see procedure for setting of compass. So first you should know how to set up a compass. So setting of compass, the compass is set over survey point. The first point is that you have to fix your compass exactly on top of your survey station, right? And the magnetic needle is allowed to align itself with the Earth's magnetic field. So you release your lifting lever, right? So this thing lever will be released and your magnetic needle is suspended on the pivot point. So your magnetic needle will automatically align it towards the magnetic north. Okay. Then what you have to do, you have to side the line using your object piece and your eyepiece. You have to first focus your object piece towards your object point towards your line or a second survey station. Then you have to you have to fix your line exactly on top of that. The bearing of a line is red of a compass, indicating a direction of line related to the magnetic north. Okay, right? So it will your uh, magnetic needle is always suspended, right? So due to this variation, your object piece, you can see the distance. I mean, a particular survey station which is aligned against your magnetic north. Then once you are aligning your object, I mean your compass towards your second survey station, right? A bearing or recorded using the prism. So there's a prism which will give a precise reading how much degree inclination of your particular angle is there. Okay, right? So that bearing is calculated with respect towards your magnetic north and providing a directional data necessary for plotting the survey line on the map. Okay, right? So this directional data is required because with this directional data you can easily fix your survey line and align your survey line with respect towards your magnetic north. That's your direction. Because when you're dealing with any maps or any other thing, so uh, the direction should be perfectly and precisely marked with respect towards your readings, right? So that is very much important to record your bearing exactly with respect towards your magnetic north. Then limitations of using this particular compass. So subject to local attraction, as I said, the magnetic needle is already magnetic and it is suspended. So there may be local attraction due to nearby metallic objects, electric lines, and magnetic influences. Right. So the limited precision compared to the advanced instrument uh, is very less when compared to an advanced instrument because, as I said, your total station will handle everything for your survey. Right? When you're comparing your total section or advanced instrument, which is required to measure the influence angle, this compass is very limited in precision. Okay? And when you are using this compass for a large or high accurate survey, it is not suitable. Okay, as I said, every reading should be done manually. If there is a human error, which is commonly occurring, so this will leads to less accurate survey. And when you are dealing with very huge area, so a lot of measurements should be noted. On that condition, this has a limitation. So it is not suitable for a large area with an high accuracy. Then we are going to see prismatic compass. So that is called the engineering compass. The key parts of prismatic compass are it has a magnetic needle with a graduated minimum range of 0 to 360 degrees. So a prismatic compass will be working on your whole circle bearing, right, in a clockwise direction. So sighting silt will be there and a wire on a vane will be there. So this is your wire on a vane, right? So this is your direction where you are going to focus your prismatic compass. So this is your sighting prism. So reflecting prism to magnify the read graduation. There is a prism inside this which magnifies your reading graduations and sunvine shades, brake pivot, lifting pin, and beveled glass covers are there. So braking pivot is to lock your magnetic needle on suspend just to mark your reading. Then lifting pin is used to suspend your magnetic needle on a pivot. Okay. And beveled glass cover is a compass cover which will protect your glass cover from breaking. Okay. Then reading system. So as I said, it will be working on whole circle bearing. So which is 0 to 360 degree. So it measures a clockwise from the magnetic north on many prism bringing figures appear reverse. Okay. For example, 0 to 90, 180 to 270 align with southwest and northeast on a ring, but a value of reading is still a whole circle bearing. Okay, right? So it is not, it may look like quadrantal bearing, but it is a whole circle bearing. So the typical least count precise measurement you can take is 30 minutes because 0.5 degree you can measure, that 0.5 degree is 30 minutes. So that is your minimum scale, right? Least count that you can measure on your prismatic compass. So temporary adjustment before doing your compass, you can see here. So this is your mirror. I will go through the parts now. So this is your mirror. So this is your object vine with a crosshair where you are going to focus your station. Then this is lifting pin to lift your object vine upright. So this is your braking pin which hold your it stop your suspended needle. So this is your pivot point where your magnetic needle is suspended. So this is your lifting lever, like to lift your hold your magnetic needle in position. So these are sunglasses which will help you to reduce the reflection. So this is your eye vine, this is your eye hole. From your eye vine, you will be focusing with your object vine and for aligning your survey station in a straight line between your eye vine and object vine. And with your eye hole, with the reflective prism, you are going to note the reading. Okay, right. So that's a thread for mounting our tripod. So these are the basic parts or components which are used widely for your measurement of your bearing. So the most important part is this magnetic needle. So this is the magnetic needle which will always align itself towards the magnetic north of the earth. Okay, right. So first we'll see the temporary adjustment. So open and inspect. So first you have to open your compass cover and check whether a glass, prism, sight line, lifting pin, and the ring are swing freely. So when you have to check whether a glass is broken or whether a prism is broken, your sighting vane is working properly, and lifting pin is lifting and holding your pivot, your magnet needle in a position, and that the ring is swing freely. Right. Then you have to do the same thing. Place the tripod over a station. So this is a primary work because your compass should be exactly above your survey station. So the uh, uh, attachment what is used for your aligning these things are it is a plumb or a drop a small stone. So the compass center is vertically above your station pick. As I said, so exactly aligning your compass on top of your survey station is a hard work. So that has to be done very precisely. Then leveling. So you have to adjust the tripod leg until your needle swings freely. So your needle should be swinging freely, so it won't touch any part of your compass, right? So that has to be done by adjusting your tripod leg, right? So without rubbing or bubble if present, it has to be centered. If there is a spirit level, it has to be centered before starting your read. Then you have to fix your zero prism focus. So slide your prism up and down to get a sharp magnified figure of the graduation scale which is on the compass. Okay, right. So you have to move up and down so that it can align accordingly so that you can read the prismatic reading in an exact way, right? So that has to be done. So the sight wire and graduation are clear, right? So your sight wire and graduation should be clearly visible when you are seeing through the eye vein and your eye hole. Okay. Then second thing you have to eliminate parallax. Okay. Move your eye until a sight wire and figure stay fixed relative to the object. Okay. You have to move your eye vein up and down so that your sight wire and figure stay fixed relative to the object line. So that has to be you have to verify. So that is the elimination of parallax error. Right. So next you are going to take the bearing. Okay. So what you are going to do, then release the needle and the ring. So gently you have to lift the pin or brake so that the ring can rotate with the with the needle. Okay. So the ring can rotate with the needle. So you are going to align it, right? Aim the line and rotate the entire instrument. Okay. You are going to aim at the line. So you have to rotate the entire instrument so that object is viewed through side tilt. Okay. So object should be viewed through sight tilt and the sight wire precisely on the object. So sight wire should be exactly aligning with your object. Then what you have to do, you have to damp the swing, lightly tap steady to the needle, ring settle. Okay, right? Once it on, you have to read make the ring to settle. Then what you have to do, read and record. Okay. So through the prism, you have to read the whole circle bearing because that's the prismatic compass. We have to use it from 0 to 360 degree read to the least count. Okay. So your reading should not be stopping with a degree. You should read to the least count. Your 30 minutes also you have to read. Okay. So if you are going for the least count, the measurement what you are taking will be precisely noted, which helps uh, to you to mark the exact direction where your sight is oriented. Okay. Then repeat an average. So again, you have to take the second reading. So then you have to do the average if needed. So you have to do the average whether this reading is proper or not because there may be possibility of error and other local attraction. So 2 or 3 times you have to take the reading. Then you have to average the reading to get your precise output. Okay. Take both forebearing and back bearing. So if you are working in a traverse, like open traverse or closed traverse, right? So you have to take from a survey point, the forebearing and the back bearing can be rotated. So at once you fix your compass on top of your survey station, both the forward bearing and back bearing you have to note. Okay, right? So because the setting up of compass is a crucial work. One setup, maximum reading where you can take from the particular station should be completed at the same time. Okay. From the next station or reverse side, now this method is demanded. Okay. So if it is needed, you can take your forbearing again. Again, if that method is specifically demanding you to do it so. Okay. So this is your first one, right? So when you're setting your instrument on station A and you're focusing on station E, so that is your forebearing with respect towards your magnetic north. Okay. From the same station, you can see the station B also. So that is the back bearing of AB. So this is a forebearing of A, E, right? So these are the two reading you can calculate from this, right? So that thing can be easily taken from this particular station. When then you are going to shift your station to station B, right? So again you have to focus the previous point. So this is your back bearing of uh, BA and the forebearing of BC, right? So similarly, after that, you are going to change the station to C, and the same procedure is continuing for all the station if it is a closed traverse. Okay, right? So this is the way how you are going to take the bearing. Okay, so as I said, a maximum reading should be completed once you set up your compass on a particular survey station. And this is the thing how you are going to take it. So from your object line, your hot scrap, you are going to focus on graduation ring. A glass cover is used. Hinge is used to move up and down. So the same component are fixed shown here. So this is already discussed. Now we are going to see the surveyor compass, right? So this is similar towards your prismatic compass, but the thing is it has vanes on both the directions. Okay. So the key parts are the magnetic needle over fixed graduation circle and sight vanes. Okay. Often a box cover, lifting pin, and brake. Similar, most of the parts are commonly used. So reading system, it is a major difference in this quadrantal bearing system. Okay. It has a reading only from 0 to 90 degree. It measures with north and south towards east and west. Okay. So the expressed with a quadrantal northeast, southeast, southwest, and northwest. Okay. So the typical least count is similar. It is 0.5 degree or 1 degree depending upon the model. These least count varies. So, sir, temporary adjustment, what you are going to see on survey compass, first you have to open and inspect, ensure your needle is freely rotating on a pivot and check your strike lines. Then centering and leveling as similar towards your previous prismatic compass you have to do. Then set the zero reference since the reading are quadrantal bearing. Ensure north and south line is recognized. So you have to ensure your north and south line. So some model have linear and fictional mark to help, right? So other model don't have everything. So some model will have this linear and fictional model. Then taking a bearing is similar to same one. You have to release the needle, let it stabilize. So you have to needle should be rotating, wobbling, and it once it will stabilize, use a sight line to align precisely towards your objects. Then note acute angle, so 0 to 90 degree, and a quadrant letter north, south first, and then east or west. Okay. So repeat everything and do the average. So take similarly, you have to take the forward bearing and the back bearing at the same time. So in a quadrantal bearing, the magnitude is same and quadrant reverse is northeast and opposite is southwest. If it is southeast and then opposite is northwest. Okay. So there are 16 directions on your thing. So this is your north direction. So this is your east. So 90 degree towards your right side on a clockwise direction is east 90 degree. Then from the east you are having a south that is next to 19 degree. From the north, from the south you are having another one which is west is next 19 degree. Okay. Then here it is divided into 22.5 degree each. Okay. So north and south the exact 45 degrees northeast. Okay. And next, the 45 degree between our east and south is southeast. Okay. Then next to 45 degree, that is 225 degree is south to east is that is west is southwest. Okay. So next to which is 315 degree is north to west is northwest. You can see that major first letter is your north or south. Okay. They are focusing only on north directions. Okay, right? So it is first quadrangle will be north in that direction, which is leaning towards east or west. So that is the condition what they are following here. So you can see here, first is a north. So next is northeast. So the direction is towards north and it is leaning towards east. So if it is northwest, same the direction is still aligning with the north, but it is leaning towards the west. Okay. So directions are one, two, three, four are major directions here, right? So north, east, south, west are major direction. Then subsequently the next directions are northeast, uh, southeast, north, southwest, and northeast. So totally there are eight directions. Still, they are dividing a direction into another thing. Okay, right? So the direction between your north and northeast is north northeast. So that is the inclination of your direction at 22.5 degree, right? So it is north northeast. Okay, right? Then the direction between east and northeast is east northeast. You can see here, as I said, your major direction is north, but when it is coming near to east, so it is very near to east, right? So that should be marked as east northeast, which is 67.5 degree. You can see here. So the direction is near towards your north, that is north northeast. When the direction is near towards your east, that is east northeast, not east east north. You shouldn't confuse with this. When the direction is near your north or south, your north northeast will come, north north inclination will come. When it's direction towards your supplementary direction inclination, so that's your east or west. So east northeast. So again, when you're moving towards the direction between your southeast and the east, the direction east southeast. So which is added by 22.5 degree. Okay. So similarly, again the direction between your south east and the south is called south southeast. Again, we are going aligning the direction is very close towards your south. So the direction is marked as south southeast. Okay. So this direction will be clearing this thing. So we came up to 180 degree. Now the direction between south and southwest is south southwest. Okay. Right. So the direction here, what we mark is south southwest. Now the direction between west and southwest is west southwest. You can see here. So this is directly focused on your direction, which is uh, west, south, west. Again, what you are going to see is direction between your west and northwest is west, northwest. You can see because this direction is aligning close towards your west direction. So the direction is west, northwest. So next one is the direction between northwest and north is north, northwest because this direction is aligning towards your north. So totally how many directions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. As I said, there are 16 directions. Okay. So when you're dealing with a quadrantal bearing, these 16 directions should be marked accordingly, right? So this is very important. The difference between whole circle bearing is whole circle bearing will give you a reading up to 360-degree, but your quadrantal bearing will be aligning only 90-degree with respect towards your direction and the inclination. Okay. So that's all about today's session, and thank you.